everybody take their seats and we'll get started again. Great presentations before lunch, and the next presentation is on new developments in cinema screen technology. It'll be moderated by Michael Karagosian, who is the principal of MKP Consulting. Michael.
Cinema screens, probably the most undiscussed technology of cinema that we have. We always talk about projectors, sound systems, color space, how much light can you get on the screen. We don't talk about the screen. And so in my investigation of screen technologies, we've had a lot of innovation in the last 5 years. And the screens that are available today are not the screens that were available 5 years ago. And I wanted to highlight that. This presentation is not about just one manufacturer, but actually about all of them. I'm going to start with for reference, we'll start with a graph that shows illumination on the screen. At the bottom, the x-axis is the width of the screen, the y-axis is the light coming off the screen. And I have a line at the top where 14 foot is our magic number for cinema. And this is plotted for a 3K bulb using manufacturer specifications for operating level, which is not the same as peak level of the bulb. And you can see by this chart that just getting to 14 foot Lambert at around a 30 foot screen is challenging on a unity gain screen. These calculations are for a unity gain screen. And when you go into 3D, it's a little more interesting. You have to automatically add a gain because you have a silver screen. The lowest gain you get on a silver screen is 1.4. So this is a plot showing 1.4 gain screens and what light levels would look like there. And the red section again is the 3K bulb with 2D. And the colors below it, blue, green, and yellow, represent 3K, 4.5K, and 6K bulbs with a highly efficient 3D system. So a less efficient 3D system, those curves would actually push downward more. But I'm showing there are a couple of systems on the market that get around 30% on polarization. And so just to sort of work with something, I picked the 30% number and said, let's just look at what those light levels are. So you can see in this chart that just getting to 30 foot, actually getting to a 40 foot screen starts to become a challenge if you're trying to reach DCI 7 foot Lambert level on 3D. And this is with a 1.4 gain screen. So if you add more gain and go to a 2.2 gain screen, which is where you'll see most of the installations today use gain screens around 2.0. Then you have a lot more options. And you can see that if you can follow the chart, blue again represents the 3K bulb, green represents the 4.5, and 6 represents yellow represents the 6K bulb. And you see you have a lot more options. It's a lot easier to reach 7 foot Lamberts with an efficient 3D system. So one of the reasons why you don't see these light levels is because all of these parameters haven't lined up in cinema yet. We don't have these better screens, and we don't have the better 3D technologies in every screen. The gain matters as well with lasers. And we talk about laser projectors as being able to put all the light in the world on a screen. But if you're just using a unity gain screen, you're not going to get to where you want to get to. The projectors themselves are very expensive. We want to sit and use these projectors on very large screens because of their expense. And so so it's desirable in those screens to buy a laser projector and expect high performance. So a lot of people are looking for 14 foot Lambert 3D. It's very hard to reach. on a screen. I think what we've got here is a unity gain screen on this plot. When you add gain, you move to a 1.8 gain screen, which is probably fairly typical gain for this kind of application. Then you have a lot more options. And this chart shows those kind of options that are there, that you can actually reach 14-foot numbers with a 2-head laser projector. And you can still reach 14-foot numbers with a single head for a number of screens, still a fairly sizable number of screens, although that's probably not where these projectors are going to appear. And it's certainly easy to reach the 7-foot Lambert level across the board. And if you just take this process and then go into HDR, you can just see that you still need gain on the screen. And it just keeps going on. So gain screens actually are quite important, and manufacturers have been putting a lot of effort into making better gain screens, which is what I'm going to show a little more depth on today. One more sidetrack on this is that in the 3D space, silver screens are quite popular. About 59% of the 3D screens around the world are silver. 92% of the 3D screens in the US are silver, and then around 50% of the screens outside of the US are silver. 50% of the 3D screens are silver. So it's a pretty high number of silver screens out there, which is further incentive for the manufacturers to sharpen up, build better product, and serve that market. The screen companies have a lot of challenges in building screens, and I'm going to walk through several of them. One of them is just putting a coating onto a vinyl substrate. And it sounds very simple, but the characteristics of the coating are quite demanding. We want a coating that's flexible, we want a coating that doesn't eat into the substrate, as you would see here. If the coating starts to eat into the substrate because the chemical reaction continues, then the screen has a lifetime. And there have been screens where they have lifetimes. The performance of the screen just simply reduces over time. And this is the reason why, is where particles start eating into the actual substrate of the screen. This has the characteristics here too. We really want the coating to be flexible for a number of reasons. One of those being that you have to ship the screen. You have to be, this is the most exciting part of designing a product, but you have to be able to ship the screen. And what you see on the drawing, or the picture on the left, is a crane dropping the screen vertically into what I believe is an IMAX cinema through a hole in the roof. You see some gentlemen at the base of that screen. This is pretty, this isn't UPS delivering the screen, this is more like a construction project. The picture in the middle shows another crane sliding the screen in horizontally through a hole in the building to get this large screen in. These screens have to be then wrapped, and the coatings have to survive. So that's part of the technology of this is how do you can build a screen and get a beautiful response in a big room. But if you try and ship it, you have a different problem. Now, one of the solutions that manufacturers come up with is particularly on big installations, is the solution on the right. And the left and middle photos are from Severson screens. The photo on the right is from Harkness. And they're showing a rig that can spray the screen, put the coating on the screen in the facility. So now this gets a little bit closer to UPS. You can fold the screen, fold the vinyl, send it into, in a more convenient form factor into the site, and then struggle with, your struggle then is how you paint the screen on the site. That's an expensive process to do, and it's not something you can scale out everywhere, but that has been done. So the holy grail for screen manufacturers is to go away from shipping long rolls and requiring long flatbed trucks, which can be very difficult outside of the U.S., where roads are not always very nice And they really do need they need something they can fit in the back of a pickup, essentially. So at least one manufacturer has been able to generate a technology based upon special coatings that can fold. It takes a day after the screen's installed for the fold marks to go away, but the feedback from the field is that it works. So it's quite impressive. This is getting the business closer to being able to use UPS. Here's some photos I took of some samples that Stevenson gave me. Another challenge that manufacturers have with coatings is the perf size. The perfs on the right are the standard perf, so-called standard perf screen. They're around 5 to 7 millimeter pitch and about 1 millimeter hole size. And this is a fairly common screen, but if you're using 4K, even if you're using 2K in certain environments, you're going to get more A. And so it's very desirable to get to microperf. The problem with microperf, especially in a silver screen, is that you'll clog the pores. You'll clog the holes with the coating. And so this is another challenge the manufacturers have had, and how you keep from clogging those holes and keep the holes intact. And so that's a challenge that some manufacturers have been able to meet, and you can buy silver screens that have a microperf structure. These drawings are from Hartness, showing some of the improved light distribution that they've been able to achieve. The drawing on the right is of an older technology, showing how showing a poor light distribution within the auditorium and an improved light distribution on the left. Presumably, I don't have a note here about what screen this is representing, but I believe it's their Claris, one of their Claris systems that they're showing here. This is a similar plot from MDI showing a 1.9 gig screen that they make that has much wider light dispersion as well. Again, the drawing on the right showing old technology, and drawing on the left showing new. These advances have all happened in the last 5 years. So to try and get a better picture of what the industry has done in terms of improving performance, I took all the manufacturer specs that I could get and put them on one graph.